So section 3.1 continued, second part, so a little terminology. We're going to look at what are critical numbers. You've been finding them, you just probably don't realize it, but it's the formal name for kind of what you've been doing with the absolute extrema. And then what's the difference in relative max and min and absolute max and min. So we're going to look at that. So first of all, what are critical numbers? Well, a critical number, the formal definition is this. So x equals to c is a critical number for f of x if f prime of c equals to 0 or f prime of c is undefined, okay, at c f of c. It's a critical number, okay? So thinking about the graph, so basically what are we saying that the slope of the graph is here? Yeah, just on this one, the slope is what? Yeah, horizontal. That's right. So then we'll talk about that. But yes, f prime of c is 0. So let's see this. So what we're talking about is if we have this picture, or this picture, or this. These are all the three situations where the slope is 0. Okay? So on all of these, so what's basically special about a critical number? It's the x. A lot of times where there's either a max or min. Not always, but it could be. Okay? So this, of course, would be a max, that would be a min, and we'll talk about whether it's relative or absolute in a second. We'll use that terminology. Okay. And then undefined, so how could you have the point, but the derivative be undefined? Can you think of how that could be? No, well, yeah, you could do that, like if it's a discontinuity. Think if it's continuous, though, first. What could you have? Yeah, a sharp turn. So there are certain graphs that kind of do that. So that right there, here, you would say it's undefined. So this is where the f prime of c is undefined. And all these are at x is c. This is at c, 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 c. So right here, it's undefined because if you try to find a tangent line, there'd be infinitely many. So like a sharp turn like that, or like an absolute value graph, a sharp turn like that, that's undefined. Vertical tangent line occurs, that's on a graph like this. So you could have a vertical tangent line there, it's undefined. So again, on these three situations, oh, and the last one is like what you were talking about, maybe like at a knob. Okay, so right here it's undefined, right? Like on a square root graph. So on all four of these, however, two of them are extrema. Two of them are maxes and mins. So obviously, even though this is a sharp turn, this would still be a what? Minimum. This is a max. Now, what kind of max? We're gonna quantify or describe that a little closer here in a second. So so just the main thing to understand: critical numbers are the x values, where your derivative is 0 or your derivative is undefined. Okay. Now, how are we going to find them? We're going to find our derivative and set our derivative equal to 0, and then how can our derivative be undefined? We'll look at that. Okay. All right. That's the other part there. So let's look at this problem here. Now, what I want to do is I want to make sure that we look at the picture first, and then we'll talk about where the critical numbers are, we think, and then why it's relative max and min and not absolute max and min. So we're going to do this problem. One thing I want to make sure that we're clear is that you have to have that C, you have to have that point. I mean, there has to be a point on there. Okay, it can't be like at a vertical asymptote where there's no. All right, so I'm going to erase critical numbers. So basically, we're just going to tell ourselves we have to have the point CF of C, and either f prime of C is 0 or f prime of C is undefined when we do critical numbers, okay? So we'll get to that. Now, so let's look at this first example. on pre-cal, can you graph this? So again, this is where your pre-cal notebook would be very handy, because I guarantee you we probably graph something very similar to it. It's a polynomial, and we graph polynomials in pre-cal around section 2.3 or 4, something like that, or 2. So chapter somewhere in chapter 2. But anyways, so let's graph it real quick. Remember, the degree of the polynomial tells you the end behavior. Odd degree, positive coefficient, it has the same end behavior as x cubed. So what's the end behavior for this graph?
Negative.
Yeah.
Positive.
Left down, right up. Right? As x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y goes to infinity. Then the next thing we found were, and again, I'm not doing any calculus yet. I just want to get the graph if I can. The next thing we did when we graphed this was we found the x-intercepts. So this is just, before I even work the problem, I want to have a good idea of some things about the picture of the problem, and then I should know where my critical numbers are going to be. So, how do you find x-intercepts? Well, you take your equation and you set it equal to what?
0.
Well, how do you solve? All right, go ahead. So you do 0 and 3. You take out an x squared, factors like this. Now, since that's an x squared and you set it equal to 0, remember that's a double root. And x minus 3 is 0, so x is 3. And what do you know about double roots? They bounce. So I got a 0 and 3. So it goes up, bounces, turns, goes there. Okay, so now I did this on purpose, because now I should see how many critical numbers there are before I even work. How many critical numbers will there have to be? 2. Very good. Because what are you looking for? You're looking for either a slope of 0 or a sharp turn. Well, can you find one of those without even using calculus? You can find one of those critical numbers without even using calculus. Which one do you know? 0 is one of your critical numbers. So I've not even used calculus yet, but I can see there's a peak right here at 0. Now, and so therefore, if there's a peak, there's a horizontal tangent line. If there's a valley, there's also a horizontal tangent line. So the other ones between 0 and 3, I know when I do my work, I should get 2 answers. We'll come back to that. Okay, now, we're going to find this location and this location. And these are called relative extrema. So I want to make sure that we're clear why this is a relative max. So this is a relative max. And why this is a relative min. Okay? I want to make sure we differentiate, or we tell the difference. I don't want to use the word differentiate. We tell the difference between absolute and relative. So we're looking more globally. Okay? If you look at this entire graph, let me ask you this. For the entire graph, is there a maximum point? No. Because it does what? Yeah, it goes up forever, continuing increases. That's a good way to say it. So since you know it goes up forever, once you think you're there, there's not one. But in this little region, right here, there's a high point. Okay? So a relative max is only relative to a particular part of the graph. It will not be an absolute max unless it's the highest point. And typically you get absolute extreme, remember, on closed intervals. Remember how I make a window around it. Typically that's where it would get. There is a way to have an absolute and a relative max or min, and we'll talk about that in a second. Okay, so relative max is the highest point relative to a specific region of the graph. It is not the highest point on the entire graph. Well, let me not put that, because just put it like that. Let me just stop this. The highest point relative to a specific region of the graph. So there's this, and then here, that's our relative min. So our relative min is the lowest point relative to a specific region of the graph. Okay. All right. So first, let's do part A. So I've not done anything here. I've not done A or B yet. All I've done is just make sure we got some terminology out of the way. And I've used pre-cal to at least visualize what's going on. This was my point to you a lot in pre-cal last year. It's very helpful to be able to visualize what's going on before you even work it. Now I know, hey, zero's got to be a critical number. I got to get a critical number between 1 and 3, or sorry, 0 and 3. All right. So now, how do we do part A? So let me just erase this. We know 0 is going to be one of them. So how do I find my critical numbers? Well, if I look at the definition, the critical numbers are dependent on what? Whether the what is what? What's the definition for critical numbers? Slope, which relates to what in terms of calculus? Which relates to what in terms of calculus for f of x? F prime, you got to find the derivative. So what I want to hear from you guys is say, hey, we need to find the derivative, and we need to see what makes the derivative equal to 0. Or how could it be undefined? Well, if you don't have a fraction for your derivative, then it's not going to be undefined. So to do critical numbers, my first step is I need to find f prime of x. Once you find f prime of x, I would set f prime of x equal to 0. You're going to see f prime of x can't be undefined, and solve for x. You should get your two critical numbers. Should take you 2 seconds. Dixon County. Dixon County. Dixon County. Dixon County. Yes. Dixon County. I remember. Dixon County. I like his stories. All right, should take you 2 seconds, right? What's the derivative?
3x squared.
Yeah, minus 6x. You can see you get a quadratic. So then I'm going to set this equal to 0. 3x squared minus 6x is 0. If I factor it, I can take out a 3x. I'm left with x minus 2, which is nice. And now I get my two solutions. 3x is 0. X minus 2 is 0. So you should have got x is 0 and 2 for your critical numbers. Okay? Notice I'm not worried about it being undefined because there was no fraction in my derivative. Okay? So let's see if that makes sense. So here, and this means that this valley is at 2. Okay? All right. Okay, now what? So now can I find can I locate these points? Right? So now that I know where they occur, can I find the actual point there? So all I need to do is do what with the x to actually locate it? Yeah, so all you're going to do, if I want to locate the relative extrema, I'm going to sub in the x values, right, into f of x. So I'm going to do f of 0 and f of 2 and see what I get. Now I needed the picture to help me to see that these were maxes and mins, because Just because the derivative is 0 doesn't mean it's a peak or a valley. And that's in section 3 where we'll investigate more on how we know. But I needed the picture to help me a little bit. So what do we get for f of 0? F of 0 is what?
0.
0. What did you get for f of 2?
Yeah, -4.
Negative 4? Okay, yeah, 8 minus 12, negative 4, which looks, I mean, it's gotta be negative, right? You look at the picture. Okay, so f of 0 is 0 is a relative max. So relative to that area, it's the highest point, and 2 negative 4 is a relative min. They may have you type it in like this, they may have you put 2 negative 4. You just see how they'll have it kind of set up how they want you to put it, okay? How could you have, how could a relative max also be an absolute max? Would that ever happen?
An even degree on the highest order.
Yeah. So the easiest one I can think of is just think of this graph. Yeah, so it's both, right? Because if you look at this, relative to here, this is the highest point, but also for the entire graph, it's the highest point. So this would be also an absolute max. You don't need calculus. It's what? 0, 0. What's the critical number?
0.
X equals 0. Critical numbers are always x's. They're the x's where the derivative is 0 or undefined. I'm gonna tell you right now, it will be hammered into you on the AP exam. You need to know what a critical number is. It is the x value where the derivative is 0 or undefined, over and over again. Okay. All right. So now I'm going to draw pictures, and you're going to draw a picture. I'm going to see if you can find the critical number. Okay. So I'll give you a typical problem here. Call this one example 2. And then I'm going to give you some equations that I want you to find the critical numbers for. Okay. So all right, so here's a question. Find the value of the derivative at the relative extrema. For example 2, list the critical numbers. Okay. So let's do part A first to make sure we're all on the same page. Find the value of the derivative at the relative extrema. That should be easy. So you're basically finding f prime of what and f prime of what?
0, -2, or sorry, 0 and 2.
Yep. So at 0, what's the slope equal to? 0. And at 2, what's the slope equal to? 0. Just it's easy peasy, just confirming that you know the slope is 0. How would you know if it was undefined? Sharp turn, okay? Sharp turn more than likely, all right? Then list the critical numbers. Critical numbers are what? I would have that definition with me at all times. If I need to go and get a fake tattoo for it, then that would be good too. X is what? X is 0 and 2. That's it. That's the answer. Those are the critical numbers. The X values for the derivative is 0 or undefined. Okay? Done. So we basically, with this example, we used what to get the answers? The graph. On this, you're going to have to use what? How are you going to do this one? On these three. Yeah, but analytically. Yeah, because technically it is algebra and calculus, right? So you got to do these by hand because you don't have a picture to look at. So what's going to be your process? Your process is going to be find the derivative, set it equal to 0, see if anything makes it undefined, and then we'll go from there, okay? So find the critical numbers for each of these. I can tell you these two will not be undefined. They should just be equal to 0. And we'll look at why in a second, okay? And then when you get to the trig one, and then that will be part 2 of our 3-1, and that should pretty much put you in good shape to finish that lesson. So let's do like a couple minutes, we go over part A, a couple minutes, we go over part B, and so on. So we should be done with this one soon. You need to remember what from algebra? What do you need to be able to do in order to find the critical numbers on part A? What math skill do you need? Factor. If you can't factor, you can't do calculus. Okay, you have to be able to factor. If you can factor, doesn't mean you can do calculus. You got to be able to factor. Okay, part A. How many critical numbers did you get?
3.
3? I got 3. All right, so let's see if that's right. So on part A, we're going to do the work down here. So the first step in finding critical numbers is you take the derivative and you set it equal to what? 0, because this cannot be undefined because there's no denominator. When we get a denominator, then to see what makes it undefined, we would set the bottom to 0. But if that point exists, I'll give you an example in a second of that. We'll do a part B. Then I'm going to set it equal to 0. I can factor out a 4x, leaves us with x squared minus 4. And then x squared minus 4 will factor difference of 2 squares, x minus 2, x plus 2. And you can see your 3 factors, set each factor equal to 0. And you get, what do you get? You get 0, 2, and negative 2. So what's going on possibly at those locations? What is possibly happening there? What's the whole point in finding these? Yeah, there's a good chance these could be maxes or mins. That's exactly why we're finding them. Is to find the extrema, to see where the maxes and mins are. So how are you going to know if those are maxes or mins? Yeah, but I can tell you, you'll get the value, but just because one is higher than the other one doesn't mean that's a max and it's a min. It does on this graph, but it won't always. So that's something else I'm going to teach you down the road is how can we also know that, okay, so you're going to, if you plug in a 0, that's an easy one. What do you get? 0. Is that a max or a min? Well, it's a min. But how are you going to know it's a min, right? There's more to it than that, right? But I can tell you that 0, 0 is a min. And when we plug in 2 and negative 2, we get maxes. So you could on this one. But like, for instance, on this one, you don't know what that looks like. So how do you know? So it is possible you can have a graph like this. So even though this point is higher than this point is a min and that point's a max. Because relative to that region, it's a min. So you see what I'm saying? So we got to be careful about looking at the y. There's a way that will solidify this in a couple of sections. But what I want you to understand is that's exactly right. What we're trying to do, the reason we're finding these is eventually we want to be able to find the maxes and mins. Because maxes and mins are the optimum values on a graph. Let's say this was an area function or a volume. A volume function looks something like this. Let's just say a volume of a box, right? It looks something like this. Well, we would want to find that peak. The reason we'd want to find that peak is what do we notice at that peak? Volume is what? As compared to here. Well, maximize volume. So there's a reason for why we're doing what we're doing. Okay? So critical numbers will hopefully could tell you maxes and mins. You don't know right now, but you're just getting in the habit of finding those. But you're right. If we were doing the little absolute extrema thing, then yes, we would kind of compare it and see. All right. So there's your critical numbers. All right. Let's do part B. What rule are you going to need to do to differentiate? Quotient rule. Okay. Now you'll get a denominator, but if the denominator doesn't equal to 0, don't worry about it. Just when you get a fraction, set the top to 0, set the bottom to 0 to get your critical numbers. Let's see what he wants. This is my principal calling me. This one, I'm gonna erase this problem here. All right, so quotient rule, I call the top U, the bottom B. What's the quotient rule? U prime B minus all over. So you'll notice your denominator cannot be 0. Because x squared plus 1 squared is not going to be 0. So U prime is 4 and B prime is 2x. Right? So you should have got those two answers. Now I sub everything in. U prime 4 V x squared plus 1 minus V prime 2x times U 4x all over x squared plus 1 squared. Well, so I got my derivative. I'm going to clean up the numerator. It looks like I get 4x squared minus 8x squared is negative 4x squared. So I get 4x squared plus 4 minus 8x squared all over x squared plus 1 quantity squared. So I get 4 minus 4x squared all over x squared plus 1 quantity squared. Okay? So now, what we're looking for is, remember, critical numbers are what makes the derivative 0 or undefined. Well, undefined would mean, can the denominator be 0? The denominator cannot be 0. Because if you have x squared plus a number, it's not going to be 0. Okay, does everybody see? You only get imaginary solutions, I and whatever. And that's even squared, so don't even worry about that. So we're just going to set the top to 0 and solve. And you should get 2 answers there. Okay? So if I set the top equal to 0, 4 minus 4x squared is 0. 4 equals 4x squared. Divide by 4. 1 is x squared, so x is plus or minus 1. Those are your 2 critical numbers. What did those stand for? Where the derivative is equal to what?
0.
Micaiah, what could it tell us? You just answered it correctly on the previous problem. What could that tell us? Could, but we don't know for sure, because it could be one of 3 things. Remember, it could be a hill, it could be a valley, or it could be a swiggle. Okay? So how do I know which one it is? That's just let it marinate for now. But you can find the y's at least. You just got to plug back in. So critical numbers are where the derivative is what or what? 0 or undefined. And for 0, we know it's one of these 3 situations. It's either a hill, a valley, or a horizontal tangent line through like a squiggle. Okay? All right. I want to do a trig one because I feel like trig is one of those, it's that beast out there that I don't think you get enough knowledge in, and I want to make sure that you can, be successful with it. So notice it's only from 0 to 2 pi, which is the same as 0 degrees to 360 degrees. Okay? Same interval. All right. So let's see. So if I take the derivative, let's work through this one together because I think the trig you may have a little trouble on. So I'm going to find my derivative. What's the derivative of secant? secant theta, tangent theta. Come on, guys. You gotta, these derivatives, especially if there's no chain rule, you gotta know it. Derivative of secant is secant times tangent. What's the derivative of tangent? Secant squared theta. All right now you have an F for today. No worries. Okay. So now, I would prefer to change it to sines and cosines. That's me. I don't like leaving it like this because you're gonna be like, well, how am I gonna solve this? This looks awful. So I would change each one of these into sines and cosines and make it one fraction. That's how I would do it. You don't have to do it that way, but I'll tell you why I think that's easier. So, do you remember the identities for each one of these in terms of sine and cosine? So secant is equal to what? It's 1 over cosine. Tangent is sine over cosine. And secant squared would be 1 over cosine squared. So if you notice, I've already got a common denominator of cosine squared. So now the top becomes 2 sine theta plus 1, and the bottom becomes cosine squared. So now I set the top to 0 and I set the bottom to 0. And I'm going to solve each of those. Okay? This is a nice problem here to kind of get the juices going again on that. So now when I set the top to 0, I have 2 sine of theta plus 1 is 0. So basically we know if I solve for sine, sine is negative 1/2. So the question is, where is sine negative 1/2? And this is where you have to use triangles to solve. This would have been something either right before we quarantined or right as we quarantined. It was one of the last things that I taught you. So I gave you like a little saying, all students take calculus. You remember this little diagram. And sine is positive in the first and second quadrants. Sine is negative in the third and fourth. So I know that this is a third and fourth quadrant angle. So this is where I think I gave you a recipe for this. So you draw the angle, you drop a perpendicular, there's your angle. You label the sides, so -1 is the opposite, 2 is the hypotenuse. What type of triangle has 1 and 2 on it? I'm asking for angles. This is one of your special triangles. It's a 30, 60, 90, adjacent negative square root of 3. So this angle here has to be 30, but that's not the answer because you always calculate your angle counterclockwise from the positive x-axis. So that would be a total of how much? If you're 30 degrees past the 210. So that's one of our answers. 210. Now I would convert it back into radians because it says 0 to 2 pi. And then I also know that sine is negative in the fourth quadrant. So there's my angle. That's my 30 degrees. So because I already know it's got to be 30-degree reference angle because I did it here. So I'm drawing the same triangle in the fourth quadrant, -1 and 2. So what angle would that be? If you're 30 degrees short of, look, 330. All right, there's your two critical numbers there, but you should put them in radians. How do I convert to radians? So I'll tell you what I do. 210 is the same as 7 times 30 degrees. 330 is the same as 11 times 30. And I know 30 is pi over 6 in radians. And that's how I convert to radians. 30 degrees is pi over 6. So 7 times 30 is the same as 7 pi over 6. That's the easiest way to convert to radians. So there's two of my critical numbers. All right, where is cosine 0? From 0 to 2 pi. So now we got to look at this bottom equation. Basically, where is cosine equal to 0? Well, then on those I use the unit circle. In cosine is where is the x value 0? Well, it's at 90, the x value is 0, and 270, the x value is 0. So these angles, whatever they are in radians. So it would be pi over 2 and 3 pi over 2. Now the only problem is, if I go back to here, remember what we said about critical numbers, that they have to exist. They have to be x's that, x values, or in this case, they're theta values, but they have to exist on the original function. And these don't, because pi over 2, when I see tangent up here, I can't plug in pi over 2 because tangent has asymptotes at negative pi over 2 and pi over 2. So those are where there's asymptotes. So technically, we wouldn't count these, okay? You would only give those two because those don't exist on the original graph. So I went back and checked. Okay, so again, what did I do here? How do I know where cosine is 0? I use the unit circle. I'm looking to see where is my x value 0. Okay? So anytime it's equal to 0 or equal to 1, sine or cosine, I use the unit circle. If it had sine of theta equal to 0, that's here. That's the y, where the y value 0, and there. So state that would be, if it was this one, 0 and pi. Okay. All right, so I won't use those because that it doesn't exist. That should just be my answer. Okay. All right, one last problem. All right, let's do this one to lock in for kind of compare everything we've done in terms of today and Friday. And this video will be done. I'm running low. I think 9:20 the bell rings, right? So real quick, last problem, example 4. Find the absolute extrema for f of x equals x to the 2/3 on -1 to 2. Okay? All right. So this is what we did Friday. So I want to connect what we did Friday with what we're doing today. So when I'm looking up, when I'm on a closed interval, remember I'm looking for the blank point and the blank point. What am I looking for? So if I'm looking for absolute extrema, I'm looking for the highest point and the lowest point, not necessarily peaks or valleys, because it's just in this box, this closed window. So the first thing I'm going to do is find f of -1 and f of 2. And I get -1 to the 2/3, and I get 2 to the 2/3. Okay, I get those two. And just to save time, this is 1. -1 to the 2/3 is +1. 2 to the 2/3 is just some fraction, right? We probably don't have that one. All right, so there's that. So if I look at my window right now, -1 is 1, 2 is like 2 to the 2/3, so it's up here like this. Okay, 2 to the 2/3 is higher than 1, it's bigger than 1. What else do I need to look for? In between here, what else could happen? Peaks or valleys, how do you find that? Or undefined. You're going to see this derivative doesn't equal to 0. So this was I gave you step by step on Friday, guys. Step 1, find the endpoint. Step 2, find your derivative. Set it equal to 0 or undefined. So I'm going to set it, let's see. I'm going to take the derivative because I'm running low on time. 2/3 x to the -1/3, which is 2 over 3x to the 1/3. That's the derivative. Notice it won't equal to 0. It cannot equal to 0 because the numerator is 2. But the bottom can equal 0. And so just look real quick, what is it that you could plug into the bottom to make the bottom 0? 0. So it's 0. But that's where the derivative is undefined. Here's an example of where the derivative is undefined, and I'll show you why. And now if I plug it back into the function, 0 to any power is what? No. 0 to any power is what? Come on, guys. 0 to anything is 0. So I get 0, 0. There. See? I go and plug back in. So I took my critical number and I plug it back in and I got 0. Now look, there's your graph. Can you find the highest point and the lowest point? Yes. And why is it undefined? Because this is it's like a check mark. See, it looks like this. X to the 2/3 comes in like a sharp turn. So which of these numbers is your maximum? 2 to the 2/3. Which of these is the minimum? 0. Don't forget how to do that. So this, in this case, since it's a closed interval, this is your absolute min. This is your, and the other one is your absolute max. X is 0 is called a what? Critical number. Okay? Critical number. It's the most important thing. If you kind of are foggy on things, I'd go back and watch the video. Go back and look at where I've emphasized critical numbers all day. Okay? So anywhere that the derivative is 0 or undefined, those are critical numbers. Okay, I'm going to stop this because